Hello students, today we are going to prove the theorem from the circle chapter. Equal chords of a circle subtend equal angle at the center. We are going to prove this theorem. Now what is given in the question? A circle with center O and the chord AB is equals to chord CD. And what we have to prove? That these chord AB and CD subtend angle AOB and angle COD at center, and we have to prove that these two angles are equal. So for proving these two angles equal, we'll prove the two triangles congruent in triangle AOB and triangle COD. We are going to take these two triangles COD. So in this, OA is equals to OC, OA is equals to OC, and OB is equals to OD. OB is equals to OD, and the reason is radii of a circle are equal, and it is given in the question that AB and CD are equal. The chord AB is equals to CD, that is given. So the two triangles are congruent by the rule that is known as SSS, because this side is equals to this side is equals to this side, and the chord AB is equals to chord CD. So these two triangles are congruent by the rule that is known as SSS congruence rule. Now since these two triangles are congruent, their corresponding parts will also be equal. So that's why angle AOB and angle COD, this angle and this angle will be equal. So angle AOB is equals to angle COD, and the reason is corresponding parts of congruent triangles are equal. So we have proved that the equal chords of a circle, these two chords are equal, subtend equal angle at the center. That means angle AOB is equals to angle COD. Now let us solve the question number 1 of exercise number 10.2. Prove that equal chords of a congruent circle subtend equal angle at their center. In this, two congruent circles are given, and we know that the congruent circles are those circles which have equal radius. So two congruent circles with center O and O dash, AB is chord AB is equals to chord CD, and we have to prove that they subtend equal angle at the center. That means angle AOB and angle CO dash D is equal, that we have to prove. Now how we'll prove it? We'll prove these two triangles congruent. So in triangle AOB and triangle CO dash D. Now in this, OA is equals to O dash C, OB is equals to O dash D. These two are equal because radii of congruent circle are equal, and also it is given that chord AB is equals to chord CD. It is given. So these two triangles are congruent by the rule that is SSS, that is side side side. So SSS congruence rule because OA is equals to O dash C, OB is equals to O dash D, AB is equals to CD. So these two triangles are congruent by SSS. Now by CPCT, that is corresponding parts of congruent triangle, so angle AOB will be equals to angle CO dash D. That means this angle and this angle are equal. This is due to corresponding parts of congruent triangle. Now let us solve the question number 2 of exercise 10.2. Prove that if the chords of congruent circles subtend equal angles at their center, then the chords are equal. In this question it is given that the two congruent circles are there having the same radius. So, and this angle AOB and angle CO'D, that is the angles subtended at the centers, are equal, and we have to prove that these two chords are equal. So given two congruent circles with center O and O dash, and angle AOB is equals to angle CO'D. This angle is equals to this angle, and we have to prove that these two chords are equal. For that we will need to prove the two triangles congruent. So in triangle AOB and triangle CO'D, we are going to prove these two triangles congruent. OA is equals to O dash C, as we know that radii of congruent circle are equal. Radii of congruent circle are equal, and it is given that the angle AOB is equals to angle CO'D. These two angles are equal. This is given in the question, and OB is equals to O dash C. Again the reason will be radii of congruent circle. Radii of congruent circle, as we know that the radii of congruent circle are equal. So therefore these two triangle AOB is congruent to triangle CO'D, and this is due to the rule side angle side, SAS congruence rule. Now since these two triangles are congruent, therefore the chord AB is equals to chord CD. This is due to the corresponding parts of congruent triangles are equal. So if two chords subtend equal angle at the center of a two congruent circle, then the chords are equal.